Somewhere it has reached a new milestone with the delivery of the NoJesi project. NoJesi is a project for the Spanish Ministry of Defense, where Somewhere is the key element for the creation of a real-time simulation laboratory. NoJesi puts together simulators and COTS in HLA and DIS, approaching and probing the LS concept. NoJesi project has meant the testing workbench and evolution of Somewhere framework and Somewhere RTI towards a truly proved open layered simulation architecture. Origin of NoJesi project. Starting in 2010, Spanish MOD has been requesting new requirements for simulation in its technology and innovation strategy for defense, called ETID. In order to fulfill these requirements, the Spanish MOD has been working with Somewhere platform since late 2010. In this past 3 years, the Spanish MOD and NADS have been working together in 2 related projects in order to evolve Somewhere simulation framework as a platform for open and interoperable distributed simulation. NoJesi project is the last of these projects. Its successful delivery has been a milestone for Somewhere technology. Completing NoJesi project, Somewhere has reached a new level of maturity. All the improvements made for this project are included in the regular Somewhere packages and are now part of the middleware. Challenges of NoJesi. NoJesi project presented some interesting challenges. Integration of legacy systems and COTS like VirForces and VBS2. Interoperability between simulated and operational systems. Development and maintenance and deployment of simulation assets as services into an HLA federation. HLA interoperability to a wire protocol level. Let's see these challenges one by one. Challenge 1. Integration of DDS, DIS and HLA. Somewhere generates gateways between DDS, DIS and HLA. Only the fields are connected. The complexity is hidden underneath. Resulting gateways are services in the simulation. The latency added is reduced to a few lines of code. Challenge 2. Interoperation between DDS, DIS and HLA. With the previous challenge, we can connect the different simulation standards. But the objective is not just connecting, but interoperating between the different tools running the standards. This means creating elements in any of them and seeing them in the rest, but also interacting with them in the rest of tools. In HLA, this means that the ownership of the objects has to change from one tool to the other. With Somewhere, we can transfer the ownership between different HLA implementations and vendors. This is achieved by using DDS unique flexibility in data modeling. This capability is integrated in Somewhere gateways by default. Also, Somewhere TR HLA implementation running over DDS has ownership transfer. Challenge 3. Different COTS and interpretations. This is maybe the most difficult challenge. Each HLA vendor and each COTS has its own interpretation of the HLA data model. All of them have their own twist in the representation of the data. Finally, coordinates and dead reckoning are not homogeneous. Somewhere deals with these differences so the user doesn't need to care about them. The unique Inquirison library makes these differences transparent to the user. Let's see now the architecture that was built for NoJesi project. The architecture of the project is represented in this slide. In the core of the whole simulation we have the Somewhere framework running over DDS. This is the central hub of the simulation. It was completely built using Somewhere framework tools. This element controls the state machine of the whole simulation, launches and manages the pure Somewhere elements, like the simulation services. Sends the ticks of the real-time scheduler to the entire simulation. The simulation services are part of this core application. They simulate the aircraft, sensor, missile and LGB simulation models. Connected to this element are Forward Air Controller Simulator. This is a complete simulator by itself that allows to simulate the entire forward air controller operation. It was developed for the Spanish MOD by Indra. In NoJesi project, a HLA interface was added to the forward air controller. The connection between the forward air controller and the core SimWare framework was made using SimWare as HLA server and a gateway between DDS and HLA made with SimWare PowerLink tool. Tactical C2 system was also connected in the same fashion using SimWare T. For forces, it was also connected using SimWare as HLA server and a gateway. VBS2, it was also connected using the same RT and a gateway. In this case, VBS2 used LVC Games interface for PLA. The PLA server in this project was SimWare T. We had also tested this environment using MacPLA. SimWare has the capability of mixing together different PLA vendors. Some of the physical machines were Linux and some Windows 7. SimWare runs the same over both OS. No Jessie project was made using LAN network. After the project finalization, most of the infrastructure has been replicated using Wi-Fi and WAN connections. Let's see now the No Jessie solution in the highest level of abstraction. What is different in No Jessie solution? In this kind of projects, the traditional approach has been to try to implement a simulation engineering methodology, like FEDEP or its evolution SIEP, with a set of software tools and processes. In this approach, new developments are focused in the system engineering, not in the deployment of the simulation. For the deployment, these projects propose some kind of wrapper or middleware that provides an abstraction of different simulation protocols like HLA, DIS or TINA. Translation code is generated by doing gateways and bridges between the different types of simulators. In No Jessie, main innovations are not in the development process, but in the simulation technical architecture. No Jessie is based on a pure distributed data-centric architecture made possible with the use of DDS. This approach follows the same concepts of LSA study group of SASO. Proposed architecture combines the use of traditional simulation standards, as is, like PLA and DIS, with the use of DDS as the common communication protocol. The architecture is the key point.